light that hits the center here is going to bounce back right through that, at that same angle. See if that works better. So I know it's going to come back through this 2 centimeters down. Bounce back to that point right there. And so these two meet about here. So what this is telling me is that this should be 30 centimeters away from the mirror. Let's find out how close we got. Spot on. I'm getting 34 centimeters. So 30 centimeters would put it about there. So I'm off. So.
To be fair, I can't really see the purple line.
Yeah. We hit dead on. So light that comes in, hits there, hits the center, it's going to bounce back through there. Light that comes in straight is going to go through the focal point, which was about there. And then light that goes through the center of the radius of curvature, or the center of curvature. Well, what is the distance to the radius of curvature from the mirror?
That's a radius, so that'd be half radius.
Therefore,
Be 15. No.
5 centimeters.
wrong way. We're looking for R.
7.5 centimeters?
No,
Or what, 20?
20 centimeters. The focal length is half the radius.
Oh, yeah.
Yeah, half radius.
Yeah, backwards.
So my radius of curvature is, that's my radius of curvature of my mirror. And so light that passes through that point hits the mirror, it's going to bounce right back through it. And notice that all our light rays there happen to hit somewhere around the same point. So we would see an image. So if we had this mirror here and I had put the object 15 centimeters from it, we would see the image 30 centimeters from the mirror. Based upon that. And it actually works out pretty well when you're much more careful with this. It is a real image. And it's called a real image because the light rays actually do meet. It's not like they appear to meet, they actually meet. So real image. It is inverted. Because if my object is pointing up, my image is pointing down. So inverted.
So that's why in the mirror, it's reflect more, it's like if you look at yourself in a mirror, it's backwards.
It is, let's be careful about that. So,
Reversed, yeah.
but not inverted.
Not inverted.
Magnification is negative Q over P. So that's negative 30 over 15, which is negative 2. So my image should be twice as big as my object. And, I'm off here, but you can see that it is bigger than the object. And the negative here tells me that it's inverted. So this is sort of, I don't have to draw it. If I got the negative here, that goes with inverted. If we look at the flat mirror, we had just written it over there. We had 1 over P plus 1 over Q is equal to 0. For the flat mirror, the focal point is infinite distance away. So 1 over P is equal to negative 1 over Q. P is equal to negative Q. So when I do my magnification, it's negative Q over P, or P over P, or 1. So the magnification of the object is 1. And it's not a negative here, which means that it's not upside down. Because when a mirror actually flips, it seems like it flips left and right. So why shouldn't it flip up and down? A mirror actually just flips front and back. That's what it flips. And all the rest is a consequence of that. All right, so we have magnification, we know where it is. All right, let's do another example that perhaps is a little less obvious. Let's keep the same mirror. So my focal length is still 10 centimeters. This time, let's put the object at 5 centimeters. So the crude sketch is I got my mirror right here, I got my focal length right here, there's my focal point, and then I'm putting the object here. Plug it into my formula there, I got 1 over 5 plus 1 over Q is equal to 1 over 10. 1 over Q is equal to 1 over 10 minus 1 over 5, which is negative 1/10.
So it's negative
So Q is
10
units.
centimeters.
So now we have a Q that is negative. Well, the positive side is the side where I expect the light to be. Negative got to be on the other side. So this image is going to appear behind the mirror. Just like when you stand in front of a bathroom mirror, which the area is flat, your image appears to be on the other side. My magnification, negative Q over P, is negative 10 over 5.
Which is -2.
Got two negatives there.
+2.
So it's going to be twice as big. It's positive, which means it's upright. The fact that Q is negative tells me that the image is virtual. And a virtual image is an image where the rays don't actually meet there, they just appear to meet there.
You say it's virtual because Q is negative?
Yes.
Okay.
Yeah.
So what would that like look like?
If you looked in the mirror, it looks like the image is on the other side of the mirror. If you're standing 2 feet away, the image is 2 feet away on the other side. That's what a virtual image looks like, because the light rays don't actually penetrate the mirror.
So what would a real image look like?
Have you seen the floating coin gimmick?
Floating what?
Floating coin. It's basically, two bowls. You got a bowl right here, you put a penny right there, and then you have another one on top with a hole at the top. There's a round hole at the top. And it looks like the penny is floating right there.
No, I haven't seen that.
Oh. It actually, it's an amazing trick. I mean, you actually do have a coin there, and if it looks like it's something you can grab, but you can't. If you're looking at it just right, it looks like something you can grab, but there's nothing actually there. But the light rays are meeting there. So it would appear like the image is actually right there in front of the mirror. Your brain is processing it, thinking there's something right there.
I'll have to look that up.
Floating coin trick. I'm trying to remember what it was called. Probably if you typed in floating coin, that would be sufficient. In the remaining 2 minutes. The other piece here is that, so concave mirror, focal length is positive, convex mirror,
All I'm getting is the refraction pointer.
okay.
Is it something like that?
No, that is not it. Convex mirror, the focal length is negative. P is typically positive. We'll get into situations where potentially it's negative. Q being positive, real image. Q negative, virtual image. For me, I can come up with the set of rules, and some textbooks do it, and I can't remember if this one does or not, where they come out with a list of basically what I'm writing down now, but if you think about it in terms of the standard, light hits a mirror, light bounces off, light meets. That being the standard, that's gonna get you your positive values. A negative value means the light's not meeting, or the mirror is not causing the light to bounce towards itself. But that will remain for another day.
I have a question.
Yes,
Is this
ask.
gonna be on the test, this stuff?
This will be on the last test.
Oh, so it's not gonna be on the first test?
No.
Okay, okay.
Yeah, first test ended with chapter 22.
Okay. Thank you.
And when is the first test?
Which was today.
How long,
Next Tuesday.
how long
How
is
many
the
questions?
test gonna be?
My days are running, the 4-hour tests are ended. Although, so, and I got into a role there where people were actually finishing everything on time. And then pandemic has sort of messed up my timing. But, basically, that's what we're doing in class that day. You'll have 2 hours. Or if you have nothing going on after this, you have longer than 2 hours.
You know how many questions are gonna be on it yet?
Yep.